Hello everybody, and welcome back to the Poor Man's Chemist. In this video, I am going to be making hexabromoplatinic acid, in hopes for using it in some upcoming experiments that I would like to do in the future. What I'm going to do is, it's very much like the bromooric acid video. What I've got here is concentrated hydrobromic acid in here. I have some concentrated nitric acid here that I made up the other day. I'm going to add a little bit of that into here, and I'm sure that will react to generate some bromine. And, oh wow, it is giving off some powerful fumes. And it will dissolve the platinum. I'm hoping that since this is precipitated platinum, it will not take forever in a fucking day like the platinum bar did. But we'll see. It's still warming up, so we'll wait and we'll see how this does. Alright, got a little bubbling action, a little fuming action going on. Ah, yeah, there we go. Nice. Now, according to Atomistry, this will go even better if we add a little bit of elemental bromine to this. So, I'm not going to be so crazy as to add drops of pure bromine, but I do have a mix of bromine and hydrobromic acid that we can add to this to speed it along here. Okay, so I lied. I am going to be so crazy as to add a little bit of pure bromine to this. I mean, it's such a windy day outside today. We just had a mild little storm front move through, so I'm not too worried about fumes. They should get diluted pretty well. Plus, I don't plan on standing up here for very long. Alright everyone, it is the next day. I am continued dissolving the precipitated platinum in the mixture of hydrobromic and nitric acids for a while yesterday, for a few hours. Kept at it again this morning for a while. Discovered that if you keep stirring it, if you do it with stirring, it goes a lot better. It goes a lot faster than if you basically just let it sit there and react and only stir it occasionally, as with gold, which, that worked pretty well for that. But anyway, not so much for platinum. So I transferred it all over into another evaporating dish. Not all of the platinum had dissolved, so I separated what had dissolved, the solution there, from any residual platinum that hadn't, cleaned up the evaporating dish and then transferred it back in here, and I've been evaporating it down here for, not very long, over boiling water. So what you see here is a solution of hexabromoplatinic acid. And the best I can tell, it is starting to crystallize out of solution, and so that's some of the solid there. So I will come back when more of this has evaporated away. But you know, this basically at this point is just evaporating it down, maybe getting it to where it's almost all evaporated, and once we've gotten most of the acid out of it, evaporate the rest of the way under vacuum and get it to crystallize. Ladies and gentlemen, I give you the Redneck Rotovap. Alright people, look at that. That is hexabromoplatinic acid that has been dried under vacuum very meticulously. We can see it is a beautiful ruby red compound. Would you look at that? I want to make sure it's focused. Stay focused on my moment of triumph, you piece of shit. Look at that. That is fucking beautiful. And, to my knowledge, nobody else has done a bromide of platinum. I don't know. I have a hard time believing that because, I mean, this... how has nobody thought to do a bromide of platinum before? Makes me think that I just didn't find it when I was searching for it. But there we go, people. Look at that. That is fucking beautiful. God, that is gorgeous. And you saw it here first. I hope. What are you doing, sweetie? What? What do you want? What? I'm trying to do stuff here. Do you mind? What? Do you mind if I, like, you know, get to work? Is that okay? No, it's puppy playtime now. Yep. Somebody pushed their on button and they decided that now it's time for everybody to run around and bark and run. What you doing, Lucky? What? What? Alright, for the second part of this video, we are going to be preparing a solution of mercuric cyanide. The way that we're going to do this is very, very simple. We are just going to create a solution of potassium cyanide in distilled water, put it on the stir plate, and at room temperature, we are going to just turn on the stirring, add little bits of mercuric oxide. This is just mercuric oxide that I prepared in the last video. And we're just going to add it in there a little bit at a time until almost all of it has reacted. Then the textbook tells us to stop the stirring and to filter off the solution. And then from there, we could go on to create the pure compound, but in our case we're going to stop at that point because creating the pure compound, I don't know that if I'm going to need to, and if I do need to, I can do the rest of it later on at a future date. So let's go ahead and get started with this. I'm going to take this here. This is 1.3 grams of potassium cyanide, and I weighed this out yesterday, but here, let's center you guys here so you can see everything. I think this is just under 18 mils of water. Let that stir for a moment until everything dissolves. Alright. Now, I'm going to go ahead and start adding in the mercuric oxide. Oh, wow. The way it read, I was thinking this might actually take a little while, but the way it's reacting, maybe not. Now, just by the nature of the reaction itself, it will turn the solution alkaline. So, I thought that was a nice little added safety feature of this reaction, which made me feel a little better about showing it to the whole world. Like someone would have to intentionally acidify this, and actually that is the next step of the reaction in the textbook. You add in all of the mercuric oxide, then you filter the solution, and then once the you have the filtered solution, then you are supposed to add a couple of drops of phenolphthalein to it, and then you're supposed to extremely carefully neutralize it with 3 molar sulfuric acid. Then evaporate down the solution, dissolve the crude product into methanol. I think it was 3 portions of methanol, and then evaporate that down to get the pure mercury 2 cyanide. But I don't know that what I want this compound for can't be done in alkaline solutions, so until I know that, I'm not going to worry about going any further than just creating it in solution here. What's the matter, Lucky? Roxy! Stop, baby. Oh, what the fuck is that? Is that a piece of the oxide? Aw, man, how the fuck did that happen? How did that even fucking happen? I'm not really sure why it's turning gray, other than maybe there's some kind of disproportionation happening, and we're getting some mercury metal out of this. Although the textbook didn't say anything about that. Whatever. Alright, that is the last of it. not quite the last of it. A little bit of it stuck to this stupid little plastic petri dish thing. But, oh well, it's disposable, so how's that going for it? Alright. It looks like it's taking longer now for it to react like this, so I'm going to let it stir here for a little while, and we will check back in here in a little bit and see how this is doing. Alright everyone, all of the mercuric oxide has reacted. There's some kind of, I don't know, some kind of dark precipitate left over. I don't think it's mercury metal. I don't actually know what it is. But if it's mercury, I would expect it to clump. At least I would think it would. But I could be mistaken. I am just filtering it through a cotton plug here. Anyway, that's pretty much it. I mean, that's our solution of mercuric cyanide. So, cool. So anyway, if you guys enjoyed this little video, give it a thumbs up. If you didn't, give it a thumbs down. Subscribe, comment, share the video. And until the next one, y'all, I will see you later.